And there it's coming up. Okay, and this class is the LO4. This is the last call for the midterm. This doesn't apply to the high schools. Doesn't apply to Udall or Ergonia, because I rely on individuals there proctoring it. But for here, the Wanton section, if you haven't taken the midterm, today's the last day that have you take it. I'll be in office today from 1:30 to 4:30. Don't show up at 4:25 because I'll leave at 4:30, so you have 5 minutes. So get in now or not take the midterm. I want to get those graded and back to everybody. And I still have about 3 people that haven't taken it. So okay. This is 3.5 rational functions and their graphs. Now, a rational function looks like this. Rational function means single fraction. So we got a single fraction. Specifically, we have variables in the denominator. That's what makes a rational function. Let's find the domain of a rational function. You've already seen this. Step 1, set the denominator equal to 0. Step 2, solve it. And step 3, put a slash through the equals. We saw this back when we were covering the domain of a function. So let's take a look at our first problem. H of x is equal to x minus 5 over x squared minus 25. Okay, so step 1, We're going to set our denominator equal to 0. Then we want to solve it. And this one, you can solve it one or two ways. I'm going to solve it using square root property. So take negative 25 over, becomes a positive 25. Square root property says if you got something squared equals something else, you drop your squared, put a plus or minus square root on the other side. And square root of 25 is 5. And then our third step is to put slash to the equals, because these are the values they cannot be. If I plug 5 back up here, 5 squared is 25, 25 minus 25 is 0. So x cannot equal to negative 5, and x cannot equal to a positive 5. Now writing that in interval notation, that go from negative infinity to our smallest number, union our smallest number to our largest number, union our larger number to positive infinity. Parentheses on everything. That's how you write everything except for negative 5 and 5 in interval notation. Now number 2, f of x is equal to x plus 3 over x squared plus 9. And same instructions, want to find the domain. Well, first step, you set your denominator, your bottom part equal to 0. Step 2 is solve that. So in this case, I'll take the 9 over the other side, becomes a negative 9. I'll apply the square root property again. So we'll drop the squared, and you put a plus or minus square root on the other side. Now, negative gives you an I, and the square root of 9 gives you a 3, so that gives us plus or minus 3i. And we saw this back when we covered, I think, section 2.1. But i's don't have any kind of meaning in the real world, so if you have an I, that drops away, and then your domain by default, you could write all real numbers, or in interval notation, it's written as negative infinity, positive infinity. Now this next topic involves limits. And I'm actually doing something with this in a couple of weeks. Okay, let's say you're getting ready to have a heart attack. Your heartbeat, heart rate, whatever it is, it's increasing. And there's a heart attack, and then over on this side. This right here, if you were in the hospital, is not so important for the hospital to be monitoring that. As I understand it, heart attacks are not like 5-hour events. They're very quick. By the time they get to your room, it's probably over. But this leading up to the heart attack, this could be a 5-hour event. I have a friend, he went to work in the morning, just was feeling off. And then as the day went on, he started feeling worse. And it almost felt like he was getting a flu. And by the afternoon, they were taking him by ambulance to the hospital. I'm not sure when he actually had his heart attack. But if he told me that this is a 5-hour event leading up to it, that's important. Now, limits means that we're going to study it as it's coming up to that point. We don't care about what's happening at that point. We care about studying this side. Because at that point, it's too late. Also important to study is this other side over here. Because I've been told you can have one heart attack after another. So, or your heart rate could beat, whatever it is, could drop so low they need to give you some kind of drugs. By studying it, they can prevent a heart attack. They can give you a nitroglycerin, I think. to prevent heart. Over here, I'm assuming they can give you something to kind of stimulate the heart too. My dad, I took care of him for 11 years, and one time we were watching a baseball game, and all of a sudden he said, I can't stand. I said, what do you mean you can't stand? You're just standing 5 seconds ago. And he says, I can't stand. And if he told me the stroke, that's what he had. A stroke takes 1 second or half a second. It wouldn't surprise me. Just like immediately he couldn't function. It wasn't like he had an episode and sat there for 2 minutes or anything like that. Now, at the moment he's having the stroke, it's too late. Just, whatever damage happens. Leading up to it, though, 20 years leading up to it, diet, exercise, all those things can help prevent strokes. Also on this side, it's important. I guess they got a pill for the stroke now. It's like they didn't have that back when my dad had his strokes. But if they give you that pill within so many hours, I'm not sure how many hours it is, then that can minimize the damage that a stroke does to your body. So again, important studying it from both sides. Not so important at that point. That point is happening. I'm going to get a screening done in 2 weeks for because the strokes run real bad in my family. So I'm going to get a screening done to see if arteries are clogged up or whatever they are. I'm not very good with biology and so forth. But anyway, that's the principle of limits. It's a calculus concept, but it helps us to understand asymptotes. Okay, so back to this problem. It says use the graph to complete the statement. Now this notation here, this little arrow, that says approaches. So as x approaches -3, the plus power, what that plus power means is from the right-hand side. So you say as x approaches -3 from the right-hand side, we're wondering what f of x is approaching. What's it going to? Now -3 is down here, and I'm coming from the right-hand side, which means I'm tracing the graph. So I'm tracing my graph here, going along, tracing it, keep tracing it. It's getting closer and closer to that dotted line, which we'll talk about here in a minute. And it keeps on going up forever. Now, f of x is your y, so it appears like my y values are going to infinity. And that'd be my answer. Now, it says that this is a vertical asymptote, x equals -3. What an asymptote is it's an invisible line your graph will skim at some point, never touching it, never crossing it. So it's going to keep on getting closer and closer to that asymptote, but it'll never touch it, never cross it. It'll keep going up forever. Okay, we got that. Our next problem. Okay, so this is saying as x approaches 1 from the right-hand side. So here's x equals 1. And again, I'm tracing my graph. Coming from the, try it again. Deselect. Okay, coming from the right-hand side, getting closer and closer to x equals 1. As it gets closer and closer to that, tracing the graph, I see that it goes up forever again. So that's another positive infinity. It's taken, boy, that's bad. 21 or 22 years, however long I've been married. That's bad. It's over 20. But it's taken that many years for my wife to finally realize something about me. I get mad at home. I lose my temper, as we all do, I suppose. And I blow up. And you can kind of tell when I'm starting to get angry. And I tell her when that occurs, just back off, leave me alone, let me go to my room. And I said, because 99% of the time I'm in the wrong. I really am. I'm not getting angry because I'm justified. There's only like 1% little amount where I'm actually right. But I just need the person leave me alone so I can calm back down. It's taken her a while, but she recognizes that now. So when she sees me going to that point, she leaves me alone. And most times I end up apologizing because, again, I'm in the wrong about it all the time. That's the idea of a limit. Before she'd push me until I went, over the deep end. And now she studies me as I'm going up to that point, and she doesn't go any further. Okay, so this says x approaches positive infinity. Now, positive infinity is over here, and you can only approach it from one side. So there is no plus, or what we're going to see is a negative power, indicating the left-hand side. So I'm tracing my graph. Here, y is equal to 3. Coming down to right here, y is equal to 2. So tracing my graph, y is equal to 1. Y is equal to 1/2, 1/3, 1/4. Knowing that this is a horizontal asymptote, I know it's not going to go down below it. It'll skim it, which means this is approaching 0. Never will equal 0, but it approaches 0. That's concept of a limit. Okay, let's take a look at this one. Now here we got what looks like a negative power. Again, the plus means for the right-hand side. What looks like a negative power means for the left-hand side. So I'm getting closer and closer. Here's a x equals. Edit. Deselect. Right here is x equals 1. So I'm tracing my graph, getting closer and closer to that. So here I'm tracing my graph, getting closer and closer to that. Where's that going? Negative infinity. Yeah, this is going down forever, isn't it? This next topic is a vertical asymptote. Vertical means up and down. So this is an invisible line your graph will skim at some point. And it's asking us to find those. So finding the vertical asymptote. Not put an S on there because you can have more than one. Step 1, back to the top, back to the bottom. Cancel if possible. And step 3, set the bottom equal to 0 and solve. Okay, so let's take a look at this problem. G of x is equal to x minus 5 over x times x plus 5. And I want to find a vertical asymptote. Step 1 would be to factor the top, factor the bottom. They're factor as much as they can be. Step 2 would be to cancel, but I can't cancel anything. They have to be exactly the same. If this was x minus 5, this would have to be an x minus 5. So then step 3, set your denominator equal to 0, then solve. So I'm going to have x equals 0 and x plus 5 equals 0, which gives us 0 and negative 5. Those would be my vertical asymptote. Unlike the domain, we don't put a slash through. Don't know what this would look like, but I know at x equals 0, there's an invisible line. Your graph will skim at some point. At negative 5, I know there's an invisible line there. Your graph will skim at some point. Don't have any clue what it looks like. You know, it might look like this. But all I know is it's going to skim it at some point. So I don't know. Number 8. Got g of x is equal to x minus 4 over x minus 4 times x minus 5. Step 1, I'm finding vertical asymptotes, would be the factor the top, factor the bottom. These are already factored as much as possible. I wanted us just to focus on the asymptote part. Step 2, cancel if possible. I notice they both have an x minus 4. So those x minus 4s will cancel. That leaves us 1 over x minus 5. And then step 3, set your bottom part equal to 0. So x minus 5 equal to 0. And solve, and that gives us x equals 5. And that's our vertical asymptote. Couldn't tell you anything else about this graph, but I know at x equals 5, it has a vertical line, invisible vertical line, that the graph will skim at some point. Questions on vertical asymptotes? Now, next topic is horizontal asymptotes, horizontal side to side. Asymptote. Asymptote. Now, remember the fractions, you have a top and bottom, numerator, denominator. You have your degree. Remember, your degree is the largest power of x. Now, we got three cases for this. Case one, the degree at the top is larger. In that case, there is no horizontal asymptote. Case two, the degree of the bottom is larger. Your horizontal asymptote is y is equal to 0. Case three, the degrees are the same. And I like to show this by example. If I try to put in the words, I talk about standard form, leading term, leading coefficient, and it just gets very convoluted. So let's say I have f of x equals seven x squared minus 5x plus 2 over 8 minus 3x squared. For horizontal asymptote, will be y equals 7 over negative 3. Now, how do we get that? Is we create a new fraction, y equals, and then we take the number off the front of the first term, the leading term, or the term with x the largest power. So the x the largest power right here is this x squared, so I take the 7 off of it. The x the largest power down here is the second term. I take negative 3 off of it. And you create a new fraction, and that'll be a horizontal asymptote. Okay, so for this problem, the instructions are to find a horizontal asymptote. Asymptotes. You can never have two. Find a horizontal asymptote, if any, of the graph of each rational function. Now, the degree at the top is 1. The degree of the bottom is 2. So the degree of the bottom is larger. The degree of the bottom is larger. It's case 2. So my horizontal asymptote is y is equal to 0. Again, don't know much about this graph, but I know at y is equal to 0, it's going to skim at some point. It may cross it. Sometimes they cross asymptotes, not vertical, but it may cross it, but it'll skim at some point. Now this problem, the degree of the top is 2, the degree of the bottom is 2, so the degrees are the same. That's our third case. Degrees are the same, remember we create a new fraction. So my horizontal asymptote will be y equals 8 over 4. The 8 comes from the number in front of the x to the largest power here, and the 4 comes from the x to the largest power up down there. So you got y is equal to 8 over 4, which 8 divided by 4 is 2, so you got y is equal to 2. Now this problem. Our degree of the top is 3, the degree of the top is 3, the degree of the bottom is 2, so the degree of the top is larger. Case 1, degree of the top is larger, or horizontal asymptote is none, there isn't any. So the answer on this one would be none. And number 12, degree of the top is 1, the degree of the bottom is 1. So the degrees are the same. So this is case 3, and we want to create a new fraction out of it. So I'm going to have y equals, and then you take the number off the front of the x to the largest power. So -4 here and 7 here. So my answer would be y is equal to -4/7. Questions on the horizontal asymptote? Now these next problems just involve our shifts and they describe the transformation. So we'll review a little bit on this. These are basic functions we have here for rationals, 1 over x, 1 over x squared. When your number is inside with the x, before it was inside the parentheses, inside the square root, inside the absolute value, inside of whatever, it shifted left or right. Here, the number will be inside the denominator. So this is going to shift left or right, opposite what you think. The +3 would make you think goes right 3, so it's going to go left 3. And that'd be my answer. Again, they'll have these in each of the sections dealing with new types of functions to indicate it works no matter what functions. Now here we got a -4 inside the denominator with the x, so that's going to shift left or right, opposite what you think. -4 would make me think left 4, so it's really being shifted right 4. If your number's at the very end or very beginning, it shifts it up or down. -3 would shift it down 3. So this is right 4 and down 3. Okay, and this time the number is inside the parentheses with the x, but still same principle. So this is going to shift right 1, down 2. And that's all I want you to do on the homework on that, is to say that. Now this next problem talks about graphing this. And so let's go ahead and graph this. X is equal to 2x squared over x squared minus 4. Well, the vertical asymptotes, remember our first step was back to the top, back to the bottom. Bottom part factors as x plus 2, x minus 2. Top part doesn't factor. Second step in finding a vertical asymptote is I'd cancel, if possible. I can't cancel anything. Third step is to set your denominator equal to 0 and solve it. So x plus 2 times x minus 2 equals 0. Set each one of those equal to 0. X plus 2 equals 0, x minus 2 equals 0. Then we get x equals -2 and x equals +2. Now, horizontal asymptote. Degree of the top is 2, degree of the bottom is 2. Degrees are the same. So this is case 3. So we create a new fraction, taking the number off of the x to the largest power. So we're going to have 2 on top. And there's an invisible 1 before this x squared, so that's 2 over 1. So our horizontal asymptote will be y is equal to 2. Another thing we want to find is the x-intercept. To find the x-intercept, you always plug 0 into the other variable. So to find the x-intercept, we're going to plug 0 in for y. So 0 is equal to 2x squared over x squared minus 4. Now, if I multiply both sides by x squared minus 4, I'd get 0 is equal to 2x squared. Divide both sides by 2. And I get x squared equals 0, which gives me x equals 0. And if I were to think of zeros, it'd have a multiplicity of 2. Now, y-intercept. You always plug 0 into the other variable, so I'll plug 0 for x. So I get y is equal to 2 times 0 squared over 0 squared minus 4. 0 squared is 0 times 2 is 0. 0 divided by anything is 0. So this would give us our y-intercept. Now, if I were to graph that, we said we had vertical asymptotes at -2 and +2. Don't know much about it, but I know it's going to skim those at some point. I said my horizontal asymptote is y is equal to 2. It's going to skim that at some point. I said my x-intercept is 0 by its nature. When it's through the origin, your y-intercept has to be 0 also. No choice on that. And I said multiplicity is 2. If you remember what that meant before, multiplicity being even means it touches at a point and goes back down. Or it comes down and touches a point and goes back up. This one's going to go down. I've never seen one go up where it crosses directly. And there's also a reason why I'm mentioning here shortly. Now we got two places we can draw this next one. I can draw it here. That's one possibility. Or I can draw it here. For it to be down here, it would have to cross the x-axis. I don't have an x-intercept down here. So it can't be down there. It has to be up here. So we'll draw a little bit better maybe. Looks something like this. I know it skims this and skims this. Now over on this side, got two possibilities again. I could draw it here or I could draw it down here. If I drew it down here, it had to cross the x-axis. I don't have an x-intercept down there. Means has to be up here. Now this was for fun. In terms of graphing, how I want you graph them, plug them in your calculator. Don't do them by hand. I just wanted to show this to demonstrate to you what is an asymptote, what's it used for exactly. But we got a TA3, TA4, paid good money for it, might as well use it. The key to this, and I mentioned this at the beginning class, is if you got more than a single number, a single variable on top or bottom, you have to put parentheses on that part. So when I plug it in, I put parentheses on top, parentheses on the bottom. Then I bring my little calculator. That's nice. I use Desmos. Desmos doesn't need parentheses, but at least you'll see it. Y equals 2x squared. And x squared minus 4. And that's what it actually looks like. Those of you who have a T83, you'll have extra vertical lines on there. Those vertical lines should not be there. Originally, I thought, well, they're putting a vertical asymptote on there for you. They're not. It's a flaw with the calculator. I mentioned this before. It's where they programmed it like an etch-a-sketch. So basically, if you got TA3, don't put those extra vertical lines you see. Otherwise, just sketch what you got. Now, it even looks worse on a T83. I recognize that. So if this was, when you're taking a midterm, I don't see your work on the ones at home. On homework, it doesn't matter, but I never penalize students for flaws in the technology. Okay, number 17. Again, I'm not going to graph it by hand. I'll plug in the calculator. Where is my calculator? There it is. X minus 3. X squared minus 6x plus 8. And that's what our graph looks like. Questions on graphing at all? That's kind of chilly in here, isn't it? These next problems ask us to find a slant asymptote. They also ask us to graph it. I'm not going to graph it, but we'll talk about how to find a slant asymptote. Vertical is up and down, horizontal side to side, slant is an angle. Finding the slant asymptote. That's also called the oblique asymptote. And how you do that is use long division. One and only place in college algebra where you have to use long division, and drop the remainder. On some problems, you might be able to use synthetic division, but there's other problems where you have to use long division. Note, you have a slant asymptote when the degree of the top is exactly one larger than the bottom. If that isn't true, you don't have a slant asymptote. Yeah, I've been upset with my wife for a few days now. Not where I could say anything or anything, just irritated. She threw my mask away. It's been the same mask I've been using since the start of the pandemic, which isn't a good thing to do because these aren't washable. But it was perfect, and I could breathe, and she gave me this new one. It's got these little things sticking out of it, and they sit there and tickle my nose constantly. She claimed the dog tore it up, but I know my dog doesn't get up from my computer desk. Not unless I had food up there, but then I don't have any food in my computer area there. But she knows how to play me. But she knows I'll never get mad at my dog. She said she threw it in the trash, and she knows I would blow up. I know, though. Okay, so find the slant asymptote. Degree of the top is 2, degree of the bottom is 1. So the degree of the top is exactly 1 larger than the bottom. So I use long division. Remember, we take a look at the first term of each, decide what goes up on top. We asked ourselves what times x gives us x squared, and that'd be x. X times x is x squared. X times -2 is -2x. I'm going to subtract that line, which means flip signs. So this become a negative, this become a positive. X squared minus x squared drops away. 4x plus 2x is 6x. And then I'll bring it down to -7. Now take a look at the first term of each side, what goes up on top. I ask myself, what times x gives me 6x? And that'd be 6. 6 times x is 6x. 6 times -2 is -12. Subtract that. That becomes a negative. This becomes a positive. 6 minus 6x drops away. -7 plus 12 is 5. Now the degree of the 5 is 0, because there is no x. The degree up here is 1. When the degree of this down here is less than what you're dividing by, this is your remainder. And we drop our remainder, and our slant asymptote is y is equal to x plus 6. Though I'm not going to have you graph this, just in general. If I went through, this would have a vertical asymptote at 2. 1, 2, 3, 4, 5, 6. And it'd have a slant asymptote at y is equal to x plus 6. If I found my intercepts, 3.5 would be an intercept on my y-axis. And so I'd know it kind of goes like this, skimming this. This would go down like this, and then there'd be a piece up here if I were to find my x-intercepts and y-intercepts. This, if you were actually graphing these by hand, like let's say going on Wichita State to take your business calc, for example. My stepson took business calc at Wichita State, and while they let you use the TA3, TA4 at home on your homework on my math lab, it's like, how could they control you at home anyway? You go and take a test. He couldn't at that point in time. That's been about 7 years ago, but he couldn't use a calculator at all on the test. So if you were taking business calc and you needed to graph this, I don't know how to do it by hand. It's good. Now, if you're thinking at Cali, I don't know of any of our instructors that teach that don't let you use TA3, TA4. But yeah, he hated that because he got used to his TA3, TA4 in the homework, and then he got the test, and it's like he's got to do everything by hand. It could be negative. Yeah, it could go the other direction also. It really requires something a little bit different here. Let me change this one, show you. If I had f of x equal to negative x to the third minus 2 over x squared plus 3. It's positive so often that you think it's always positive because nobody ever designs a problem where they put a negative there. They could. I mean, there's nothing wrong with having a negative there. Degree of the top is 3. Degree of the bottom is 2. So degree of the top is exactly 1 larger than bottom, so it has a slant asymptote. I'll do my long division, putting 0 placeholders for my missing powers. Okay, take a look at the first term of each side. What goes up on top? We ask ourselves what times x squared gives us negative x to the third, and that'd be a negative x. Negative x times x squared is negative x to the third. Negative x times 0x gives us, 0 times negative 1 is negative, or 0, and x times x is x squared. Negative x times 3 is negative 3x. Going to subtract that, which means flip signs. Negative x to the third plus x third drops away. 0x squared minus 0x squared drops away. 0x plus 3x is 3x. Now bring down to minus 2. Notice the degree of this is 1. The degree of what I'm dividing by is 2. So this is our remainder, and we drop it. And so our slant asymptote will be y is equal to negative x. Which means, like you say, this will have a slope of negative 1. So it never comes back. There it goes. Questions on the slant asymptote? We're done with that. So let's take a look at next section, 3.6, polynomial and rational inequalities. Solving polynomial inequalities. Step 1, get everything on the left side, 0 on the right side. Step 2, set the left side equal to 0 and solve. And these are our critical values. Step 3, using the critical values and the x-axis, build a table of intervals then, using the graph, figure out your answer. If you got a greater than or greater than or equal to, answer is above the x-axis. If you got less than or less than or equal to, your answer is below the x-axis. If you got less than or greater than, you're going to use parentheses. If you got less than equal to or greater than equal to, use brackets. High schools never did connect. This class gets done at more or less 12:30. Next class is 12:30 to 1:30. Then I'll be in my office from 1:30 to 4:30. So some of you already heard this, but some of you connected a little later. If you haven't taken the midterm, today's your last chance. I'll be in my office from 1:30 to 4:30. It's in the technology building behind this building. There's only 2 buildings here, so it's the one you don't go into. I think room 106. I'm in the back. There's just not that big. Don't show up 4:25, but you have 5 minutes. But I will leave at 4:30. I think Popeye's Chicken's calling me. Sure sounds good. Did I get that? Okay. Let's take a look at this problem. Okay, x squared plus 4x minus 5 is less than 0. Step 1, get everything on the left side, 0 on the right side. That's done. Step 2, take your left side, set equal to 0, and solve it. Notice in my steps, I don't say how to solve it. Each of these problems will be different. This one you can actually factor. So using PSD, this factors as x plus 5 times x minus 1. Zero factor property. Set each factor equal to 0. You get negative 5 and positive 1. Now step 3. Using the critical values in the x-axis, build a table of intervals. Well, here's my x-axis. Here's negative 5. Here's positive 1. Now those split these into intervals. That's what the critical value does. Clear over here is negative infinity. Clear over here is positive infinity. So my first interval is from negative infinity to negative 5. My next one's from negative 5 to 1. And this last one is from 1 to positive infinity. So that's what we mean by that. It then says, then using the graph, figure out your answer. Well, if I graph this, and specifically you want to graph it at the point where you have 0 on one side. So I graph that. Plug that into your y1. And I'll show this one. Where's my graphing? So x squared plus 4x minus 5. Now, once you look at the graph, you'll notice something that crosses at negative 5 and crosses at 1, which corresponds to our critical values. That's what the critical values indicate in this process. So if I graph it, and it doesn't have to be precise in any manner, get something that looks like that. Do not take any time to try to make it look good. That's not the goal of graphing it there. Goal of graphing it is to figure out our answer. Now our problem says less than. Less than says our answer is below the x-axis. Now what I mean by that is we're looking for where our graph is below the x-axis. Well, here's the x-axis right here. Where it's below is right here. So this is going to be our answer. So we're going to have negative 5 to 1. Now, it's a less than. Less than here tells us that we need to use parentheses. What I mean by that is we put parentheses around these. Parentheses indicates it doesn't include -5 and 1. So every number in between -5 and 1, but not -5 and 1. And that would be our answer. Questions on that problem? Okay, let's take a look at number 2. (15x² plus x minus 2 greater than or equal to 0. Okay, step 1, get everything on the left side, 0 on the right side. That's done. Step 2, set the left side equal to 0 and solve it. This factor is using the key number. Plus 2 minus 1. Set each factor equal to 0. So I got 5x plus 2 equals 0. 3x minus 1 equal to 0. So that gives us 5x equals -2, or x equals -2/5. This one I take -1 over, it gives me a +1. Divide both sides by 3, and I get +1/3. Okay, step 3. We want to use our critical values we just found, build a table of intervals. So here's -2/5. Here's +1/3. Clear over here is -infinity. Clear over here is +infinity. These split them up into intervals. This first interval is -infinity to -2/5. This next one is -2/5 to 1/3. This last interval is 1/3 to +infinity. Now, if I were to graph this, and some of these don't have to graph, because you can see it. Remember, x² is a U-shaped graph, parabola. A positive number in front of it means it opens up. Since it's U-shaped and it opens up and has to cross at these points, you know your graph's going to look like that. Now, greater than or equal to. Greater than or equal to says our answer is above the x-axis. So we're looking where our graph is above the x-axis, which is right here and right here. So we're going to have -infinity to -2/5. We'll have 1/3 and +infinity. Greater than or equal to specifically tells us to use brackets. Now, put bracket on -2/5, bracket on 1/3. Infinities always have parentheses, but you can never reach them. And if you have 2 or more intervals, you connect it with a union symbol. Now, if you're big on doing these by hand, what you would do is if you're doing it by hand, instead of looking at the graph, you choose test cases. So you choose a value between -infinity and -2/5, like -3, -1. Choose something between -2/5 and 1/3, like 0, and something greater than 1/3, like 1. You'd plug each one of those up in the original inequality and see which ones gave you a true result. The ones that were true results, which would obviously be this one, since we said that's right answer, and this one, that's how you get this. So it's kind of tedious. Graphing makes it a little bit easier. And I don't know why I put negative or a +1 there. That should be a -1. Not that matters. I'm not going to do it by hand. Okay, number 3. Got x squared less than or equal to 3x plus 3. Okay, step 1, get everything on the left side. So I'll bring the 3x over, I'll bring the positive 3 over, because you have to get 0 on the right side. Process doesn't work unless you do that. So step 1. Step 2, set it equal to 0. So I got x squared minus 3x minus 3 equals 0. Then solve this. This doesn't factor, so we have to use quadratic formula. A is 1, B is -3, C is -3. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. So I have a -3 plus or minus -3 squared minus 4 times a times c all over 2a. So we got x is equal to 3 plus or minus square root. -3 squared is 9. -4 times 1 is -4 times -3 is 12. All over 2. Gives us 3 plus or minus square root of 21 over 2. Assuming I didn't screw up. The fact that they're not nice doesn't matter, as long as we put the smaller one over here. So 3 minus the square root of 21 over 2 is less than 3 plus the square root of 21 over 2. Now, if you wanted to put those in decimal form, that'd be no problem. But again, it doesn't matter because I just know they split them up into intervals. Now, our problem is a less than or equal to. And we got an x squared, positive x squared, which means it opens up. You could graph it if you want. That'd be our graph there. I said less than or equal to, so we're looking for where our graph is below, which is right here. So our answer is between those two values. So you got 3 minus square root of 21 over 2, comma, 3 plus the square root of 21 over 2. No memory. Less than or equal to. Less than or equal to says we're going to use brackets. So there'd be brackets around these. And that's our answer. Good so far on these? Okay, next problem. Instead of being a quadratic, it's a regular polynomial. Got x to the third plus 7x squared minus 4x minus 28 less than 0. Same steps. Step 1, get everything on the left side, 0 on the right side. That's done. Step 2, set the left side equal to 0 and solve it. Now this would factor by grouping. I group first two terms together, last two terms. First two terms have an x squared, and that gives us x plus 7. Second group has a negative 4, and that gives me x plus 7. Now they both have an x plus 7, so I'll factor that out. And that gives us x squared minus 4. Now x squared minus 4 is the difference of two squares. So it factors as x plus 2, x minus 2. This lag is something else. I think it's Zoom. Because when I do this recording and I'm not sitting there waiting 3 or 4 seconds for my writing to catch up to. Okay, zero factor property, set each factor equal to 0. All to say if I could actually see what I'm writing, it would look better. Not much, but. And then solve for x. So I take 7 over, it gives me negative 7. Take the 2 over, it gives me negative 2. Take the negative 2 over, it gives me positive 2. Okay. You have to make sure you arrange them from smallest to largest. So I got negative 7 first, negative 2, and then positive 2. Again, they split them up in intervals. If I were to graph this, again, graph it when you get 0 on one side. Plug that in my TA3, TA4, or if I did it by hand, I know that a leading coefficient test says a positive number here, an odd degree, means down to the left, up to the right. And if I were to solve it and I come up with this, each one of these gives me a single answer, single 0, which means it crosses. So I know my graph without even picking up the calculator is going to look like that, more or less. Now our problem was a less than. Remember from our instructions, it says that a less than is something. Less than, your answer is below the x-axis. So it's below here, and it's below here. So this will be negative infinity to negative 7, and this one will be negative 2 to positive 2. Now it's a less than. Less than tells us parentheses. So less than is parentheses. Now infinity is always parentheses, but these will be less thans. And then if you got 2 or more intervals, you connect them with the union symbol. And that'd be your answer. One more polynomial. This is an oddball case. Okay. X squared minus 4x plus 4 less than 0. Step 1, get everything on the left side, 0 on the right side. That's done. Step 2, set the left side equal to 0 and solve it. This factor is using PSD. Factors is x minus 2 times x minus 2 equals 0. Or x minus 2 squared equals 0. Then I'll set the x minus 2 equal to 0, and I get x equals positive 2. This is our critical value, but even more than that, if I think about my multiplicity, when you have an even power, multiplicity is 2 or even. When you have an even power, it means it touches at a point. That helps me to understand what in the world I'm doing if I'm doing this by hand. If you're putting it in the calculator, it's going to be obvious anyway. Okay, so that splits it up. Here's our first interval, negative infinity, 2. Here's our second interval, 2 to positive infinity. It's a positive x squared, which means I know it opens up, touches at a point. So this is coming down, touching at this point, and then turning around and going back up. Because that's what it does when you have multiplicity that's even. Now the less than. If I go back and look at my instructions, less than is where your graph is below the x-axis. There's nowhere it's below the x-axis. So this would be a no solution. This is one possible oddball case. There's a lot of different ones. And that's polynomial inequalities. Now next time we're going to go into rational inequalities. So we'll pick up next time right there. Don't forget, if you haven't taken the midterm, get in.